Hi guys, welcome back. This is Algebra 1, Lesson 4, if you're following along at home. Saxon book, 3rd edition. Today we're going to break this up in a couple of different pieces. We are going to be talking about real numbers, and you actually won't get into non-real or complex numbers until you're in Algebra 2. But as far as real numbers go for right now, there's a really good explanation in the book. If you're following along, like I said, it's on page 15 here. We talk about, natural numbers and the number line, counting real numbers, that kind of thing. It's definitely worth looking over. As a friendly reminder, you're going to be doing a lot with number lines in algebra. So here is what a number line looks like. Typically 0 is in the middle, and then I can never remember, I don't know what's up with my marker there, sorry about that. I can never remember which direction it goes. So for most of you though, you're right-handed, that's the direction it's gonna go. We put a 0 here, and by that I mean it's gonna go in the positive direction towards the right. So the further right you get, the higher the number is going to get. 3, then to the left in our negative direction, we go -1, -2, -3, right? That all sound familiar? Good. With that said, we are going to do some multiplication and division of fractions. For most of you, this should just be a reminder. However, it's good to get this practice in order because from now until forever, you will be doing fractions, okay? Taking a look, like I said, on page 17, actually, 4E, there's a problem such as this. For A, we have 4 over 3 times, let me move that up just a little bit, 4 over 3 times 7 over 5. And as we get a little further in algebra, that X for a times, I don't want you to use that anymore. I want you to use a dot or parentheses, okay? Now every once in a while I'll slip back and use it, but for the most part going forward, you're gonna wanna use that, okay? Good, when we multiply fractions, just as a reminder, we multiply straight across the top. So 4 times 7 gives us 28. And straight across the bottom, which gives us 15. Now, because you're in Algebra 1, you do not, this is an improper fraction where our numerator is larger than our denominator, okay? You do not need to be converting that into a mixed number. The only time you'll probably want to convert it to a mixed number is when you're graphing it, putting it on a number line, because then you kind of got to know where it goes, right? So you just multiply straight across the top, straight across the bottom. Sound good? So for our division, we have to do one extra step here. So for our division, we're going to do one extra step. For problem B here, we have 4 divided by 3, 4 over 3, 4 divided by 3, divided by 15 over 8. Now, we can never divide fractions. What we do instead is we multiply by the reciprocal, okay? Multiply by the reciprocal. You may have heard this called keep, change, flip. Keep, change, flip. We keep this guy 4/3. We change that to a division, from a division to a multiplication, and we flip this last guy, 8 over 15. 8 over 15. And then we just treat it like we would a normal multiplication problem, okay? So this would give us 32. And on the bottom here, we would have 45. I had to think about that for a second. 45. Any questions on that? Let me know. Okay, so otherwise it's just normal multiplication problem. So now on some of these, I would love it if you could cross cancel first. So for example, for C, cross canceling, it's for your own benefit. It's going to make it a lot easier because whenever we multiply, divide, add, subtract fractions, whenever we're dealing with fractions, your answer must be in the lowest common, or I'm sorry, the most reduced form, okay? You can save yourself some time by cross-canceling before you get to the solution. So looking at C here, we have 7 over 3 times 30 over 9. 7 over 3 times 30 over 9. And the way we would cross-cancel this, 30 is really just 3 times 10. So I'm gonna rewrite that. 3 times 10, okay? So what I have here is, because we multiply straight across the top and straight across the bottom, 7 times 3 times 10 over 3 times 9. What we can do here is cancel these guys out, and we're left with 70 over 9. Now you don't need to rewrite it like that every time. In fact, what you would do is 7 over 3 times 30 over 9, and you would cancel this one out. That would give us a 1, because 3 times 1 gives us 3. Cancel this out. So we divided this by 3. We're going to divide this by 3. We'd get a 10. So that's what it should really look like. But if you need to do this extra step in the meantime, that's totally fine until you figure it out. So cross-canceling will save you. Cross-canceling will save you. All right, so now we did talk about improper fractions and mixed numbers. If you look at example E, actually, yeah, I just skipped D because it's more cross-canceling. But example E is 2 1/2 times 5 1/3. Quick refresh on this. This is a mixed number. We want to put it into an improper fraction before we deal with this. We're going to take this and multiply it by this. 2 times 2 is 4, plus 1 is 5. So our new fraction is 5/2. Times 3 times 5, 15, plus 1 gives us 16 over 3. Okay? Now looking at this, I can probably cross-cancel. Divide this by 2, I get 1. Divide this by 2, I get 8. Okay? On the top, I get 40. On the bottom, 3. And there's your answer. Now you can leave it like that. However, I will say that if you have to graph it, you're going to want to put it back into a mixed number so you know what's going on and where it goes on your graph. Also, if you start with a mixed number, it's technically proper that you put it back into a mixed number. So in order to do that, we do 3 goes into 40. How many times? 3 goes into 40 how many times? I think it's 13, but let's just double check. 13 times. Okay, and our denominator stays the same. 13 times 3 gives us 39, which means 39 to 40 is 1. So that is our mixed number. All right. Mixed numbers. Good, now we're gonna try that again. This time we are going to use we're gonna do division with mixed numbers. So looking at F, we have 12 1/3 divided by 2 1/6. We're gonna do first steps first. Let's get it out of that mixed number form and into improper fractions. 3 times 12 is 36, plus 1 is 37, divided by 3, divided by 6 times 2 is 12, plus 1 is 13 over 6. That's our new expression that we need to simplify. All right, so now we're going to take that and do 37 over 3. We're going to keep that. We're going to change this to multiplication. We're going to flip that last one to a reciprocal, okay? If I take 3 and divide it by 3, I would get 1. Divide 6 by 3, I get 2. Okay. So on the top we have 37 times 2, which gives us 74. And on the bottom we get 13. Since it started as a mixed number, let's turn it back into one. We're going to do 74 divided by 13. That gives us 5 and some change. 5 and some change. So we're going to do this. 13 times 5. And that gives us 65. From 65 up to 74 is 9. So there's our answer. There's our answer. Okay, now just as a refresh for some of these other ones, for G, we have a fraction over a fraction, 3 1/3 divided by 2 1/5. This is called a complex fraction because we have a fraction in the top and a fraction in the bottom. We're going to treat it very similar to what we did before. 3 times 3 is 9, plus 1 is 10, so 10 over 3. Over 5 times 2 is 10, plus 1 is 11 over 5. Now, this guy right here, let's back up. And I said when we do like 7 times 3, you can't use that as a multiplication anymore. The other thing I want you to ditch now that you're in algebra is this guy. We do not use that division symbol anymore. What we use is a fraction bar, and that's what we have right here. That fraction bar means division. So you could rewrite this as 10 over 3 divided by 11 over 5. And then now it's in that division. We keep that 10 over 3, change that to a multiplication, and flip that last one over. Excellent. Now, we can't cross cancel anything because 3 is a prime, 5 is a prime, 11 is a prime, and 10 is 2 and 5, but there's nothing on the bottom we can cancel out. So we're just going to multiply straight across the top, straight across the bottom. Now, it started as a mixed number, so let's turn it back into 1. 33 goes into 50 one time. 33 times 1 is 33, and from 33 up to 50 is going to be 17. Okay, so there's your answer. All right, so let's take a peek. As I said, this is going to be kind of a long section, but I wanted to also go over the next part, 4.f. These are symbols of equality and inequality. And they've got a good example here. 5 plus 2 equals 7. That guy equals, it's equality, right? Equals. 5 plus 2 does not equal 10. And the way we write that is we put a line through here. Does not equal. Good. Excellent work. All right. So the next part of this lesson is our basic operations: addition, subtraction, multiplication, and division. Make sure you go through those and review those. If you have any questions, let me know. Be happy to sit down with you and help. In 4.h, we talk about review of operations with decimal numbers. Adding and subtracting decimals. We have to line up our numbers. There's some good examples here for you to do those. Dividing, let's talk multiplication, because there's a couple different options here. So 4.3 says, all right, we're going to multiply 4.06 by 0.016. And in the book, there's a 0 before the decimal. That's, again, part of that silent math, things that we don't necessarily always see, right? Okay. So what we're going to do here is we're going to completely ignore those decimals, Now, folks watching at home, if your parents are watching right now, this is how they would normally do it. 406, and then that's just 16, right? You got this, right? We do multiplication. 6 times 6 is 36. 6 times 0 is 0, plus 3 is 3. 6 times 4 is 24, and then we have another 0. I'm going to get rid of this guy right there. Now we do a 0 for the next line. 1 times 6 is 6. 1 times 0, 0. 1 times 4 is 4. Then you add all those guys up, and we get 6496. Now, what we do is we look at the original problem and we count the digits that are behind decimals. 1, 2, 3 digits here. 4, 5 digits are behind decimals, which means we have to go from here over 5, 1, 2, 3, 4, and 5, which means we got to add a 0 there. So our answer is 0.06496. Now, that's method 1. Method 1. For some of you, you will have seen method 2 and your parents will not have. We call this the box method. Seems a little bit cumbersome to do multiplication like this, but I'm going to tell you, as you go on in algebra, you're going to be using the box method for other things. So this is a 3-digit number. This is a 2-digit number, which means we need a box that is a 3 by 2. 3 by 2. There's my box, okay? 406 is 400 and 0, and then 6, right? Because it's 0 tens, right? Then for this guy, it's 16. 10 and 6. 10 and 6 give us 16. So 406 gives us 406. 10 and 6 give us 16. Now what we do is we multiply. So we have 400 times 10. So 4 times 1 is 4 with 3 zeros. This is going to be a bunch of zeros, right? 0, 0. 6 times 10 is 60. 4 times 6 is 24 with 2 zeros. 6 times 6 is 36. Good. Now we're going to do some mental math here. 24,000 is 6,400. 60 and 36 is 96. Add those up, we get 6. So basically, I just added everything that was in those squares. 6496. Our decimal is at the end. Same rules apply. There are 5 digits behind decimals. So we go 1, 2, 3, 4, and 5. So this is method 2, and I love doing, that was a terrible box. I love doing multiplication by this method because it's a lot faster mentally, but it's personal preference, whatever you want to do. Okay, so just remember multiplying decimals, we count the digits that are behind decimals and we move that over. All right, next one is division. So we're dividing 6.039 divide by 0.03. Again, I'm ditching that 0 that's in front of here. You don't have to put that. That's sort of a math that's just known. Okay, so what we want to do is we're dividing this by that, so this guy is on the outside, 0.03. Then we got our table. This guy goes underneath the table. Now, over here, we can never ever have decimals, so we have to have a whole number. In order to get a whole number, I'm gonna move this over 1, 2 spots. If I do it to that guy, I gotta do it here, 1, 2 spots. So really the problem that I have now is 3603.9, okay? We bring our decimal up. How many times does 3 go into 6 without going over? 2 times. 2 times 3 is 6. Good, and then we've got, you wanna see if we've got, okay, yeah. Then we have, so that's 0, we bring down a 0, we get a 0 here. And then go ahead and just bring down the 3. 3 goes in 1 time, 1 times 3 is 3, bam, 0, bring down the 9. 3 goes into 9 3 times. There is your answer. There is your answer. Oh, because 3 times 3 is 9, and we get 0, right? If you have any questions about long division, I have some other videos that I can direct you to so that you can focus more on that. I just wanted to remind you with the decimal. Good. So next, all right, I'm gonna stop it here for now, and I'm gonna do a part 2 on unit multipliers. So thank you so much for joining us. We'll go from there. Actually, you know what we'll do now? On page 21 at the bottom, it says practice. It says perform the operations as indicated. Go ahead and pause the video and then we'll work through those problems, okay? We're gonna go through A through F. So here's A. 4 1/2 times 2 4/5. 2 4/5. Again, we're gonna put these into improper fractions. So 2 times 4 is 8 plus 1 is 9. 9 halves. Times 5 times 2 is 10 plus 4 is 14 over 5. Let's do some cross cancel. We can divide this by 2, we get 1. Divide this by 2, we get 7. 63 over 5. How many times does 5 go into 63 without going over? 12 and change, so we're going to convert this. 12. 12 times 5 is 60. From 60 to 63 is 3. There's answer A. All right, B, we've got 3 1/4 divided by 1 3/8. Again, we're going to convert those into improper fractions. 4 times 3 is 12, plus 1 is 13 divided by 4. Divided by 8 times 1 is 8, plus 3, 9, 10, 11. There we go, 8. Now we're going to keep this guy, 13 over 4. We're going to change that, and then we're going to flip this. Again, we can cross cancel. Divide this by 4, we get 1. Divide this by 4, we get 2. 13 times 2 is 26 over 11. 11 goes into 26 2 times. 11 times 2 is 22. Up to 26 is 4. Any questions on that? All right. Let's do, so now we have C. We've got all those numbers we need to add up. As you're writing them down on your own paper, make sure that you are lining up those decimals. So we have 47.123 plus 8.416 and plus 705, helps me to write it backwards, dot 4. I'm gonna throw some zeros in here so that I have some placeholders for all these guys, okay? All right, so on this guy, what we're gonna do is add this way. We get 9, 2 and 1 is 3, 4 and 4 is 8, plus 1 more is 9. Bring down that decimal that you've nicely lined up. 7 and 7 is 14, plus 1 more is 15, plus 5 is 20. 4 and 2 is 6, and then we bring down our 7. So there's your answer. Okay, that was C. Let's try D here. Same idea, but this time we're subtracting. So we have 800.62 minus 75.88. All right, got to borrow from here. So I'm going to throw a placeholder in there. All right, so 5 here, 12. So that's going to be 4. Can't borrow from here, so we're going to come all the way over here. 7, 10, 9, 10. We're going to borrow here, and we get 15. Okay, so that's going to be 7. Bring down our decimal. 9 minus 5 gives us 4. 9 minus 7 gives us 2. 7 minus 0 gives us 7. There's your answer. All right, a couple more, and then we'll call it good on this video. E. We got, actually I'm gonna write this up a little bit higher. We have for E, we have 47.05 times 6.42. We are going to disregard those, and I'm gonna do this actually the box method way, but we're gonna disregard those decimals. We have a 4 by 3, which means I need a 4 by 3 box. All right. My box is going to need to be a little bit bigger. Sorry about that. Okay, so there's a 4 by 3. Man, I am terrible at this. So 4,005 is going to be 4,705. 4,700, 0 and 5. 642. All right, 6 times 4 is 24 with 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. Giving us a big number. I'm throwing some commas in there just so I have some, I can see where I'm at. 4 times 4 is 16 with 4 zeros. Okay, 4 times 2 is 8 with 3 zeros. 6 times 7 is 42 with 4 zeros. 4 times 7 is 28 with 3 zeros. 7 times 2 is going to be 14 with 2 zeros. Then all these are zeros, so that's nice. 30. 5 times 6 is 30 with 2 zeros. 5 times 4 is 20 with another 0, and 2 times 5 is 10. All right, so we're going to line all these guys up, okay? We have 2, 4. Then we have 160. Then we have 8,000, which I'm just going to combine with that. So 4, 2, 8. And then we got 1, 2, 3. Then we have 28,000. Then we have 1,400. Actually, let me add all these guys up first. Cross them off because I put them on my list, and then we'll combine the rest of those. So we got all these guys. 1, 2, 3, bam. 8 and 8 is 16. Carry the 1. 6, 7, 8, 9, 10, 11. 1, carry the 1. 8, 9, 10. 0, carry the 1. Yep, making sure I got that right. 3. Good, bring down those commas. Okay, so what we have is, and I'm going to get rid of all those zeros on the side there. All right, we have 3,016,00123. All right, now we're gonna add all the rest of these guys. 3,000 and 1,400 is 4,400. And then 210, I can even just add that on here, 610, right? All right, we have 3, 0. Oh, let me back up. Let me go the other way. Sorry about that. Sometimes I like to try and do things mentally and it doesn't work out. 1, 6. This we got to carry. That's why I had to back up. Goes right over here. 2, 0, 3. All right, so we got this big old long number, right? Original problem. We have how many digits do we have behind decimals? 1, 2, 3, 4. So we're going to come over here. We're going to go 1, 2, 3, and 4. So we have 302.061. And even though there's a 0 on the end here, we can just get rid of that. Excellent. Okay, then let's look at the next guy here. We have okay, so then we've got One more. All right. So for F, we have, oh, accidentally used a wet eraser. Sorry, guys. All right. So for F, we have 4.028 divided by 0.04, which means this guy goes, it's in the front, so this guy goes under the table. So it's going to be 4.028 divided by 0.04. I have to move this guy, because we can never have a decimal here, 1, 2 spots, which means I have to move this 1, 2. So I have 4 divided by 402.8. Now, just looking at this, mental math is going to save you a lot. How many times does 4 go into 400 without going over? I'd say 100 times, wouldn't you? 100. 100 times 4 gives us 400. Subtract that, we get 2. And don't forget, we're going to bring our decimal up, but we don't worry about it down here. So when we subtract, we then bring down. 4 goes into 28 7 times. 7 times, and there's your answer. Excellent. Okay, I will do a second session for unit conversions. Thank you for joining me for this one.